Hello everyone, thank you very much for joining me. Today we discuss an essential subject in using cryptography functions. We discuss about the integrity of data, how we ensure integrity of data, and how we ensure authenticity, which are two very important essential characteristics in data storage and transmission. And in my opinion, any developer, regardless of their experience, should know at least the basics about this. We will also understand how we can apply this with the JDK. You will see that the JDK has already integrated functions and capabilities for this, which is great. You don't need an external dependency unless you want something more advanced, which is rarely the case. And we are going to implement this today and understand what integrity is, what authenticity is, how you can simply put them on with the capabilities the JDK offers you. And I hope that it will be a great video, or at least you will consider it useful. Thank you very much for being here with me. If you want, you have the live chat on, so in case you are watching this live, you are together with me now, you can always leave a message in the live chat and I will keep an eye on the live chat. If you are watching this recorded, the comment section is there for you, and of course you can always follow me on LinkedIn and Twitter as well. I'm going to share my screen because I think the most important is to first start with the discussion that you are interested in, which is first of all, let's put on the paper. So I'm going to put some theory on, and then I'm going to jump in the code and prove these two things that I'm going to discuss, and which are the essential characteristics about data security that we care. It's four of them that you usually need to understand and take care. So one of them is, of course, integrity. The second one is authenticity, and this is basically what we discussed today. So we discussed about two of them, and maybe later on I will put a video or more videos to discuss the others. But integrity, authenticity. We have confidentiality. And we have non-repudiation. So together we discuss about the first two today. And point is, let's first go through the first two, through the definition. So what exactly is integrity and what exactly is authenticity? So sorry for my writing is, of course, I'm a software developer. My writing is perfect when I use the keyboard, but not really good when I use the pen. But that's it. So integrity means you have like data transmission. Okay, so say app one can be microservice, because I know you guys love using the term microservice for some reason. So I'm gonna put this as well here. And you know that in service-oriented architectures, services call each other. So a microservice might call another one, send some data. And now what we discuss here, it works regardless on whether there are two applications communicating, or sometimes you simply use a browser to upload or download something. It's whenever you want to ensure that what has been sent has been received, you need to refer to the integrity of the data. So the question is here, when M2 has received some specific data, was it the one that was exactly the way it was sent by the other application? So that is the first question. That is integrity, making sure that nothing happened, like it hasn't been changed throughout the transmission of the data, regardless which are the components. So we know that network will never be 100% stable, and for reasons there are possibilities that the content of the data is altered, and for many applications it's very important to verify that the data is indeed sent, is indeed received the way it has been sent. So that is the integrity. No, you want to say M1 asks for a payment of $3 and M2 for any reason receives 5. Okay, this means the data integrity has been lost because the data that has been received is not the one that has been sent. And of course, in this case, you might end up with problems. Like in this case, you will pay $2 more on whatever this is, payment or whatever you think it is in my theoretical example. So how can we ensure integrity? That is one question. Okay, how do we ensure integrity? Integrity can be ensured easily using hash functions. So hash functions in cryptography might be very useful to ensure integrity. The most used here being the secure hash algorithm functions, which are available in 4 flavors: 0, 1, 2, and 3. And you should never actually use the 0 and the 1. So only SHA2 and SHA3 are those that you should use at the moment. Okay, so as much as possible, make sure, of course, 0. I don't think it's even used. Like, it's very old. But 1, you will still find this one, and I will even show you where you find it, because actually Git is still using it for design reasons, and you might still see that SHA1 is used now and then, especially if older applications have been designed using it, but they haven't been designed with having in mind that sometimes crypto algorithms might get deprecated. One of the advices I would actually give you is make sure whenever you use a crypto algorithm anywhere, design your application in such a way in which you make sure that the algorithm can be easily changed, because, well, with time, some algorithms might become deprecated because they might become considered unsecure. What does that mean? Well, all these crypto algorithms, they are based on a lot of math behind the scenes, a lot more math than I can understand. So I will not try to explain it, because I don't understand it properly yet, and probably ever will understand it properly. But point is, the math that creates an algorithm can also be cracked. So if a very good mathematician throughout time finds a way to distress an algorithm, then that algorithm becomes deprecated and it's considered vulnerable. So that's basically what happened with SHA0 and SHA1. And you might wonder, actually, why do we have 2 other algorithms that are considered proper to use today? Maybe you wonder why didn't they stop with SHA2 and they created also an SHA3? Or maybe are you wondering, is SHA3 more secure than SHA2? I would say no. I'm not 100% sure if it's not, but the purpose wasn't to create necessarily a more secure algorithm. It was actually to make sure that there is already available an alternative in case someone finds a problem with SHA2. Because you see, if at some point SHA2 will become obsolete, if that will happen, okay, for any reason, then you already have another algorithm that you can use, which even if it's called SHA, so the same, it's created on a totally different mathematical basis. So it's very unlikely that someone cracks both of them at the same time. So if one of them is cracked, the other one should be still useful. So you have an already existing non-vulnerable alternative, which is very important. You have a redundancy in the algorithms. So today, regardless of using SHA2 or 3, any of them is considered secure enough. Okay. Yeah. Okay. Now we talked about SHA a lot, and now you know the alternatives. You might anyway already have heard about this SHA, the secure hash algorithm. It's an abbreviation, no, but let's talk more about hash. We might have discussed about hash functions also. So, but I want to make sure that everything is in place and you properly understand the whole discussion that we have today. So hash functions, first of all, have the characteristic of you give them an input, you apply the function, which is a mathematical function of the input, you get an output. But this output is nothing that holds information from the input. So there is no reason, no way, no nothing of going back. You cannot find, you cannot have, and there isn't any function that goes back from the output to the input. So hash functions are not encryptions. They are not they don't somehow held the data from the input. They are simply a way in which any input is transformed into an output. And a very important thing, of course, this is an information you need to remember, that output doesn't hold information from the input, which means you cannot go back from the output to the input. The second thing is that there are theoretically no chances of having two different inputs that give you the same output. This is called a clash, and normally there isn't any, but if there is, now normally there are very few chances, so you cannot exploit this. But normally a hash function mathematically should have no possibility of having a clash. So two different inputs give you the same output. And there is one more thing that helps us. Usually it's regardless on how big the input is, the output will always be of a defined length. So for example, you might choose this length. So for example, you might want to obtain an output of a specific number of bytes. Say you want to have an output of 256 bytes. And that's why sometimes actually in all the cases, when you refer to SHA, you define two different things. You say SHA, what kind of SHA, and how many bytes the output should have. Okay. Now, when in Java you see SHA without the number, it defaults to 2. So you should be no worried, it's not 1, it's 2. If you don't specify the number here, you will automatically default on 2. So you can say SHA 256, and that means you apply on the output the SHA, the secure hash algorithm 2, and you will obtain an output of 256 bytes based on the input. Why is it important that you always get the same size? So let me actually now put a break on my drawing, because I'm anyway not really good on that, and do something that I'm better on, and that's writing code. So let's say you want to have some input. This input, maybe the string is not actually a good idea. Let's already start with an input of type byte array. And the reason is I don't want you to understand that the only thing we can use is strings. So for me, for a theoretical example, it's very easy to get an array bytes out of a string, but remember that you can get an array bytes out of any kind of data. It can be a file, the file can be a text file, might be a binary file, I don't care. It can be any file, any kind of data. The way we represent it in a computer today is in an array of bytes. Okay, so in my example here, I use a string for comfort reasons. I don't want now to lose time reading files. That's something, if you want to learn how to do, follow my Java Fundamentals playlist. We don't need to discuss it here. But once you have the byte array, that's the data, and the byte array, you obtain it out of any kind of data. And that's the data, for example, you want to calculate the SHA, the hash of. And to calculate the hash of, you simply have to apply the message digest object, which comes fortunately with directly through the JDK, so you don't need any special library. In my case here, maybe you wonder, I have created an empty project before just to save time, but it's nothing than an empty project using Java 21 in this case, which is again not very essential, and no dependencies. So see, in my POM XML file, I have no dependencies at all. Okay, so everything I'm doing here is using capabilities of the JDK. I'm not going to discuss now about the Java security. I have other videos on that. I will create some more. Let's now focus not on how the code looks like in the Java security APIs, but on literally what the hash does and how you do it. And of course, you have to provide the algorithm. So you can say, I want to use SHA2 with an output of 256. If you want to know all the algorithms that you can apply here, you can find them directly in the documentation. Well, I just found here the documentation from Java 11, but of course you have, the only different thing on Java 21 is that you might have, and you have more algorithms, but they are irrelevant for our today's discussion. So important is you find this in the documentation. I have shared this with you also in the chat. Maybe I will put it also in a comment later. And here, for example, you can find everything that you can use on the, it should be on the message digest as well. Earlier today, I searched for the MAC, which message digest, here it is. So you can see the message digest, what exactly can we use? MD message digest 2, MD5, message digest 5. We don't use this anymore. Remember, MD5, MD and MD2, they are obsolete. Don't use them anymore. They are here for compatibility with the past reasons, but don't use them. And then you have SHA, and you can say, I want to use SHA1, don't use it, but you can use SHA2 for different kinds of outputs, and SHA3. Okay, so you can see here they are all the algorithms that you can use. I think, can I actually put like that? I'm not even sure. Much better. Okay, stupid me. So anyway, the point is nothing changes a lot. It's only maybe different algorithms that have been added, because of course throughout the time in different Java versions you have different algorithms. The point is you have, let me actually share you the updated link. You have a documentation where you find all these names, so you don't have to know by heart what the JDK offers you. And then you say, okay, sorry, you say SHA256, which is a very common way, and say I want to digest the input. Digesting meaning applying the hash function, and then I get the output as a byte array. And very often when you want to print it, you need a hex representation. Now, how do you create a hex representation? You can manually go through the bytes and apply the integer 2 hex string to it. Fortunately, with Java 17, another util class has been added to the Java util package, which is called hex format, and you can use this one if you are using Java 17 or above. So you can just say format the output as a hex, and you have the formatted output, which for example you can put it in the console to see it. So you will see in the console how the output looks like. Now what you will observe is that you will get a similar output, different but similar in terms of number of bytes, regardless of how big or small the output is. So you can have here a large file, or you can have a very small string like I have in my case, but I will always have an output of the same length. This is very comfortable in the end, and always different, no? Because what we talked about earlier, we don't have clashes, so you will not find two different inputs to generate you the same output normally. Now you will find this approach very common when having this kind of download capabilities on the web. So whenever you have some place on the web where you want to download something, you will see this being applied. And I took here as an example Maven, which is a tool that we all maybe have used. Java developers should be very comfortable with Maven. I do expect that any of you watching this video now have seen at least and know at least a little bit of Maven and how to manage dependencies with Maven. Now you also might be aware that if we are going here, you can manually download, and what I want to show you is something that yeah, it's not really visible when you download the dependencies directly through the tool. Like you use the POM XML file to put the dependencies there. Some things happen behind the scenes, so there are some checks done over the file that is downloaded. What kind of checks? So any kind of executable, any kind of file here, you will see it's accompanied, is followed, is comes together with another file that has a dot and then some naming afterwards, usually the name of a hash function. So you see we have here MD5 and SHA1. If you go in that file, so it's the file itself, you see this very large file, which is the whole dependency, the whole Spring context dependency, and Javadoc dependency in this case particularly, sources, and then the jar file itself here. And then together you have the possibility to choose. So seeing this .sha1, you will find the sha1 hash computed based on that file. So this is the file, and this is a file containing only the hash code, sha1 hash code in this case, of that specific file. Why do you need something like that? Because when you download, for example, and I'm now going back to this ugly, let me actually create a new page for us. Yeah, and when I'm in the browser or app 1 and I'm downloading something, whether it's a response, can be a HTTP response, it can be, I know, somehow I get some information. Instead of getting only the data, I also get the data SHA, for example. Normally it should be SHA2 or SHA3, so don't use SHA1 or MD5, what you've seen in case of Git. For some reasons, we still use SHA1. It's not very insecure, okay? Don't get me wrong, but it's not considered secure enough anymore, okay? So normally if you use now, do use either SHA2 or 3. So you get these two pieces of data. No, you don't get only one. You get the real data and you get the computed SHA. So what you can do here is compute again the SHA based on the received data and compare it with the other one, the other file you get. If they are equal, then it's fine. If they are not equal, then it's not fine. And this offers you integrity validation over any mechanical things that can happen with the data in transition. But it doesn't offer you, of course, and that's what we are going to discuss next, it doesn't offer you, unfortunately, a security over someone who has intercepted the data. So if you have a hacker going in the middle and intercepting the full response, they can calculate the SHA on the altered data. So they can change the data with something else, they calculate the SHA on that something else, and then they send you this, which you will find out as being correct, which is called authenticity actually. So it's the second thing here, not integrity. So what I mean is that this approach here only offers you, ooh, such an ugly heart. Let me try it again. Not much better, but anyway. I will never be able to make a living out of drawing, I guess. Anyway, it offers you integrity, but it doesn't offer you authenticity. So when I use this approach with SHA 2 and 3, I am sure that mechanically, for any reason, the data hasn't been altered, or I can find if it's altered. Because if something gets altered, it will either alter this and not this, and then it's a failure, it will be rejected, or it can alter not the data but the SHA, and of course then you will reject properly received data, but it's better to reject something if there was anything rather than not reject. Or both of them have been altered, but they can't be altered in such a way in which there is a proper SHA computation. No, it would be like impossible. No. So this way you are sure that if you received data and it corresponds with the SHA, then it means that you have integrity. The data has not been altered. And that's exactly what you validate with Maven and Git when you use them. Here, oh, I'm not sure where my browser is. Here, okay? And that's exactly what you have this on the server. So this offers you a possibility. Hey, I'm using Maven. I want to download this dependency in Spring context. Automatically, Maven also checks against the hash file, and this way you make sure that the download worked properly, and what has been on the server, it's what you have received. Good. This is excellent when what you want to check is only the integrity of the data. But again, the problem is here, what happens when the bad guy alters on purpose the data? Well, as I've said, so this doesn't offer you authenticity. It doesn't offer you a way to know that the data is exactly as A2 has sent it and it hasn't been altered meanwhile by someone else who is our hacker. So because the hacker intercepts in a way or another the message, changes the data. No, so you have the hacker goes here, your data says that you have to make a payment of $5. The hacker intercepts the data, changes it to $10, whatever, and also changes not only the data, this is D prime, but also changes the SHA on D prime, because there is, when you apply SHA or any other hash algorithm, there is no secret that you use. Anyone can do that. You can do that. So if I get any data, I can apply simply in 5 lines of code, as you can see with Java, SHA, and calculate the hash of that data. And it's always going to be the same, because that's the whole purpose. So if you really want to make sure that the data hasn't been altered by someone, then you have to implement authenticity, which you implement using a HMAC. So this HMAC is very similar, and it actually uses SHA 2 or 3, but it also uses a secret, such that when you have a transfer of data between 2 points, the data and the MAC are sent, but in order to validate, in order to generate the MAC, you need to have a secret. And unless you know the secret, you will not be able to alter this, because you will not be able to generate the MAC. So somehow this approach for authenticity works very similar, but instead of guaranteeing our integrity, it also guarantees the authenticity, which is what you want to use in case you want to make sure that someone didn't alter. Oh, I'm sorry. I wasn't. Sorry. Ah, damn. Where's my remarkable? I wasn't sharing. Yeah. Sorry for that. So I was saying, yeah. I was saying that if we want to implement authenticity, we need to implement HMAC, and this HMAC uses also a secret. So when you have the communication between 2 different applications, instead of sending the data and the MAC and the hash, you send the data and the MAC, and this MAC, what is different from a hash is that you cannot generate it without a secret. So unless somehow the hacker finds out the secret, which is possible, but less likely if we correctly apply security processes and policies, then the hacker will not be able to generate this and fool you here, which means that this approach offers you both integrity and authenticity. What it doesn't offer you, well, it doesn't offer you confidentiality and non-repudiation. And this is something that we will discuss in a next video, in a different video, but it does offer you integrity and authenticity. Okay, so cool. So let me actually go back to the code and show you how we implement. So this is actually how do we call it? Integrity. And then I will create a different file, authenticity. And we will have to generate a MAC for that. So the difference is we will not generate a hash digest, we will generate a MAC. And what will the MAC have different is that you will need a key. So I will say something like that, byte key, and then you will need a key somehow, which is kind of like a password. But normally you should not put it yourself like that. You should randomly generate it, and I will explain it immediately. But let's focus now. You have the key and you have the input data. Again, input data, it can be an array of bytes that might come from anywhere, like it might be a file, and usually it is a file or something else. And you generate a MAC. So in the, again, the Java crypto capabilities offered with the JDK, you have also the possibility to generate a MAC with, and you have to specify what algorithm you want. So one of the algorithms that is very often used is the HMAC using SHA to 256. Let me throw the exception because we don't want to focus on that now. And then you get the MAC like that. How did I know this? Well, same thing I have shown you earlier. You find it in the documentation. So you have MAC algorithms. These are all the supported algorithms for generating MACs. Okay. So that's how I know what string should I put there. And then when you do apply the MAC, which is actually before you do apply the MAC, I think it's actually also when you apply the MAC. No, when you apply it, no. But before you apply it, you need to specify the key. So it's mandatory you specify the key that you use. And this is something like key secret key spec is the implementation, and I need to specify the key itself. I mean the data, which is some data, usually random data that I take. I here used the bytes of the string 1 2 3 4 5, but normally it shouldn't be something like that. Okay, and then the algorithm, which is again something you find in the documentation. Let's call this K and this one key. And now I use the key here, and I have another exception, but for simplicity reasons, I want you to focus now on something else. I will simply throw exception, okay? And then the final on the input, on the input will generate you the output, which is the MAC itself. And same what we did, you can just apply hex format of the output to get the MAC itself. Something like that. So what is the difference that we observe between integrity and authenticity? What is the main thing that makes a difference here? You will basically see very similar outputs, no? So if you look at the output itself, there is nothing that triggers you anything about the difference. But if you take a look at the code, you will see that here we didn't use any secret, while here we have used this key, which is secret. So it's called secret key for a reason. Only those parties that work in the communication should see this in order to verify and generate the MAC. In such a way, considering that a third party, a malicious individual, a hacker, not knowing the key, will never be able to alter the message without the parties noticing that. So that's the difference between integrity and authenticity, but it also implies that you have the key itself. Now remember that the key should be generated properly, and for the key generation, I recommend you use secure random class. So don't use the Java util random class or any other kind of random generation capability. Use a class, use a capability that offers you the guarantee of true randomness through the system entropy. Secure random from the Java security package is a good choice here, and you can usually easily generate I think let's do it like that because it's easier. So var secure random, and then you say new key, you specify the length you want for the key. Jesus. And then you just populate it using the secure random next bytes, something like that, okay? And then of course the length here depends on how large you want the key to be. Anyway, regardless on how you do that, make sure that you generate the key properly and you have a secure key and not some kind of string that can be easily anticipated. But yeah, that's basically it. So I think with this we can say we managed to explain the integrity, the authenticity, and even apply them with the JDK. And I hope that now you understood properly the difference. Now on the next video that I will create in this let's say mini series, we will discuss about the confidentiality, and for the confidentiality we need encryption. So we will discuss about using generating encryption using symmetric and asymmetric keys, and of course non-repudiation. So this hopefully will be some very interesting videos also. So integrity and authenticity, that's it, and hopefully was good understood. I also see, do we have a question? Secure random depends on the entropy of a system. Say could deployment kindly explain this is how it affects key generation. I don't understand the question, I'm sorry. I really don't understand what you want to ask. So if you have a cloud deployment, this kind of secret values, they are kept in a vault. The vault should be an independent software that you use to manage the secrets. So the keys themselves might even be generated by the vault, or if they are not generated by the vault itself and they are only managed by the vault, they will be stored centralized in the vault, and that's where in the deployment they will be taken by the applications running in the cloud. Now, if you want me to explain this, I would suggest we take this in a separate video because it's a long discussion. I mean, it would take me like more than a few minutes to discuss it properly. But the point is, here, of course, I didn't focus on where you store the secret. This is not something you generate like I do here. You generate it, you store it somewhere, and then your applications use it. So I discussed separately about generating the key and then using the key itself, okay? But you will not generate it by your application. It should be, this piece of data should be something that you generate upfront, you manage correctly, you keep it in a centralized, specialized software for that, which is called the vault, and you rotate these keys from now and then whenever appropriate. So it's key management. I think it's a different subject that we can discuss separately. Cool. Thank you very much, everyone. So I'm happy that you were here with me. I hope that you enjoyed this video, and looking forward to see you later for a different talk. Thank you very much. Have an excellent time for study and see you soon.